Hello everyone. So we are in the final phase of the data analytics lifecycle, and that is to operationalize. So what does that mean, to operationalize? Well, up until now we've actually been, we've encountered a problem. Stakeholders come to us with a need. They're trying to solve a business problem or trying to meet a real world need. And then we went into data preparation. We discovered kind of what the sources of the data are and what we're going to get. In data preparation, we actually acquired the data sets, started to prepare them, started to clean them up, maybe do some visualization on them, which will lead us to actually planning out the kind of model that we would want to create. So as we plan out the kind of model that we would want to create, we start thinking about the different parameters and how we might want to look at the relationships between the variables and those kinds of things in the data set. And then we actually build a model. So we'll go through, and the model building process, a model testing process, may be an iterative process. It may not be something that we just build a model and it's perfect. We may have to go back and change it and adjust it and fix it and try it out with different sort of settings. Once we get a model that we think is kind of as good as we're going to get, then we can communicate the results. We were either successful in supporting the hypothesis that was first stated in the discovery phase, or the data don't show any sort of support for that hypothesis, which means that that is a failure. Again, not in the traditional sense of failure. It is a failure in that it shows us a different direction to go. So up until now we've done all that, right? So let's assume that we get to a place where we've had a successful model and we see that we are able to, say, do multiple variable linear regression, and we're able to actually accurately predict with some measure of confidence a particular dependent variable that is really of key importance to us. And this could be a really good example. A good example of this could be Zillow. Zillow takes in a number of different variables, and they use those variables, neighborhood, size of house, those kinds of things, to basically do linear regression and predict the price of a home or the price of a property. So it's assumed that we've done something similar to that. Well, now that we've got it modeled, the model is done and it's refined, we have to remember that we did this for a reason. It was either to solve a real business problem or to capitalize on a business opportunity for our organization. So now it's time to put it into production. And when we put something into production, it's very rare that we're going to run something once. If we put a lot of time into it, it's probably something that's going to become part of our standard operating procedure. It could be a way that we, provide data to a particular website or web field. It could be a way that we process client records and do something with those client records. It could be a way that we run marketing campaigns. But the point is that if we're going to put all this time into a pretty good sized data analytics project, it's probably going to be something that we're going to use more than once. So it's time to put it into a production environment and build it into the production environment so that it can be on its way to becoming standard operating procedure. But at this point, though, we have to recognize that a larger group of employees are going to be impacted. In fact, it could be if you were to run it into, say, a customer support organization or a customer service organization, you may be impacting hundreds of agents that are working around the country. So you have to make sure that your implementation of the project follows some good project management implementation guidelines. I'm not going to talk about those. Those are outside the scope of this class. If you've taken a project management course, you'll have a good idea of how you implement a new project and how you create that kind of change, that level of change. One of the things we might think about is, so far we've kind of been playing around with the data. We've been playing around with our analysis in a sandbox, and that's seemed to show positive results. But if we're kind of leery or kind of risk adverse and don't really want to take the solution live in a full production environment, we might run a pilot study. And the pilot study could be run, it's going to be bigger than the sandbox, and it's going to actually be run in a real production environment. But it could be run in a real part of the real production environment that represents kind of the full production environment, but yet is still segmented off from the rest of the organization. And the reason why we would do that is because now when we're outside of the sandbox and we're dealing with much larger data sets, we can check real-world performance. Not only speed performance, but we can also check accuracy of our model. Our model was built on a training set, validated on a validation set, or multiple training sets and multiple validation sets. But every data set is different, and there may be nuances in the live data that we were planning for. So this gives us a chance to check it without impacting too many parts of the organization. But assume that we validate through a pilot study and everything still continues to look good and our level of accuracy in our model is good. Then we can go ahead and make the determination of when we're ready for full production. Once we put it into full production, we are going to need to, build in some ongoing monitoring. Models can go off the rails if they're hit with data that they're not expecting. And while we may have trained it on good training data, and we may have validated it on good validation data, and we may have even tested it on several test data sets, there's still that possibility that the model will return bad results. Not every model is perfect. So what we might want to do is we might want to monitor the performance and see if we can build in 80 parameters that will show us a decline in accuracy. If there's a decline in accuracy, even if it's just a slight decline in accuracy, how might we retrain the model? Using maybe some of the production data sets, we could retrain the model and we could set the model up to be a little bit more robust and a little bit more accurate. We might also build in out-of-bound alerts. And these are, for example, if the model throws out an outlier, a value that is something that is kind of way out there, it could be something that gets sent back to a system administrator or somebody saying, hey, wait a minute, this doesn't look right. This is beyond the limits of the parameters that we built into the model. I want you to take a look at this and determine what's really going on here. Again, the best way to illustrate this is through an example. So I'm going to go to the Universal Bank file from last term. If you remember, the Universal Bank file was a listing of 5,000 customers. Universal Bank had sent them an offer for a credit card. And so the customers who were interested in the credit card or the loan or whatever it was returned the offers. And what Universal Bank had found is they got a very, very low return rate. And so we went through and we used logistic regression to look at the data set to determine, who were the likely candidates to actually return loans, and then what were the parameters that were associated with them as far as, whether or not they used online banking and whether or not they were investment people, what their education levels were, that kind of thing. So that would be essentially the model that we created. We would have trained a logistic regression model to analyze collections of records. It could be 5,000, 10,000 records as they came in, and to segment out those who fit the model and were more likely to return the offer of a loan. So we would build and deploy the model and get it tested and get it integrated. It would work on the data set that we used to build it, of course, and it would work on the data set that we used to validate it. But when it came time to put it into production, we would need to make sure that it worked in production. So there's where we might pull a pilot test or do a pilot test that would allow us to determine the extent to which it is actually acting as well in pilot production as it was in development. And once we had validated that it was actually working well in pilot production, we'd be ready to roll it out to full production. Once we did that, we would build in some parameters to allow us to monitor that model to make sure the model isn't excluding records that it shouldn't exclude or isn't including records that it should include. And that could get down to, if we're going to take 5,000 records and we're going to limit that down to 500 records, and we're only going to send the offer to those 500 records, we would expect there to be a fairly good hit rate. If that hit rate suddenly declines, or if the number of records selected suddenly changes, then that might be a red flag for us to take a look at our model again and say in production, the production parameters have shifted, and so now this is a little bit different. So that rounds out our conversation about the data analytics life cycle. And there is plenty more to learn about it. But I just wanted to go over those 6 steps so that you understand that as a data scientist or part of a data science team in an IT group, your job would be to work with a multitude of different people, not only your business stakeholder, but others who will be impacted by the solutions that you produce and roll out and put into production. There will be a little bit of this in your final project, so I hope you got as much out of it as I hope you did.